Welcome to today's video. Today we'll be looking at the merge two binary trees algorithm. We are still on the Shem-Prashad algorithm series. It has 180 algorithm questions, and currently we're on the 25th algorithm. So let's get to it. So we are told that we are given two binary trees, root 1 and root 2. Imagine that when you put one of them to cover the other, some nodes of the two trees are overlapped while the others are not. So you need to merge the two trees into a new binary tree. The merge rule is that if two nodes overlap, then sum node values up as the new value of the merged node. Otherwise, the not null node will be used as the node of the new tree. Okay, so I have to return the merge tree. The merging process must start from the root nodes of both trees. Okay, so we had root 1 and root 2 here. Okay, so these two overlap, the root nodes overlap, so 1 plus 2 gives 3. 3 and 1 overlap, so 3 plus 1 gives 4 here. And 2 and 3 overlap to give 5. Okay, 5 and there is nothing here, so it's just 5. 4 and nothing, so it's just 4. 7 and nothing is just 7. Okay, so it's possible that they are empty, since they have told us that it's possible there is 0 item there. Okay, all right, so let's go to the board and see how we can put this up. So here we have our board. Let's come and let's have the scenario we had there. So these are the two binary trees we have, and so what we expect is that when they combine together, this will be 3, this here will be 8, this here will be 10, this here will be 7, we have 8 here, and we have 9 here. This 3 is a combination of these two, and 8 here is a combination of 3 and 5. 4 here, this 10 is a combination of this 4 and 6. 7, because here they don't have the left, so 7 takes over. Because this does not have 8, so 8 takes, and then 9. So basically this is what we are trying to achieve. So how can we go about this to solve this? So off my mind, I'm thinking that there are few scenarios here. So we have the first scenario when they overlap. So when they overlap, that means both of them are not null. So the value here, there is this, for example, this node has a value and this also has a value. So in that situation, we want to combine it. So when both of them are not null, we want to combine it. Okay, so on the left side, we want to check on the left. I want to compare the left. So for example, this left and this left, do they exist? Since both of them exist, that means they overlap, so we add them together. We go to the right, since both of them exist. Okay, so that is an answer. So for the right also, when both of them exist, we sum them up. So this is another left. When the left exists and this one doesn't have any, so the left will take the place of that. And when the right exists, the right will take the place. So that is 4 scenarios then. So we have when, okay, so yes, we have 4 scenarios. So when both are not empty, when both are not empty, we add. Then when the left is empty, so but when we talk of the left now, we have left 1. When left 1 is empty, then we use left 2, right? And the same thing when left 2, right 1 is empty, we use right 2. Okay, all right, So let's just go ahead and see how we can get this out. Okay, here, so as usual, I will just have my, so I think this will be void. I don't think I'm returning anything because I want to, so what I'm thinking of doing, let me just write this. What I'm thinking of doing is actually to use the already existing node, which is, for example, root1. So at the end of the day, I want to return root1. So I want to make use of the actual data that is there. I don't want to create a new one. So in that case, we have our 4 scenarios. The first scenario, let's say when, for example, our left, so the root on the left is null and the root 2 on the left is not null. So this is first situation. So because I'm returning root 1, so if the left on, if my root 1 is null and root 2 is not null, so I think I will just put this, I'll just set this to the root 2 dot left. And the reason why I'll be doing this is because, so take for example, we had, let me just draw, so here now you see, of course, this and this overlap. You see this and this overlap, fine. Also, in fact, this and this overlap, fine. So those will sum. But for example, you see that this on the right, on the root 2 exists, but on the right here it doesn't exist. So basically what I want to just do is to copy everything here and just come and paste here. So it will just have, I'll just copy it all here. That's the idea. So basically I'll just be setting whatever is on this right, for example, to what this is, knowing that this one holds the reference to these 2 children and it keeps going that way. So it means I will not even need to go and iterate at the children of that particular place, since I know it already, I've copied that, since it's a reference type. So basically, and I want to return, I don't want it to bother going to the next ones. But if this is on the left, so I have to do for the right also. If the right is null and root 2 left is not null, sorry, it's right, sorry, it's not null. So here I want to say root 2 dot left, or rather right, I'm on the right, is root 1 dot right is root 2 dot right. So basically doing the same thing, and I want to stop it there. So this is the second scenario. The third scenario, because okay, what I'm thinking of doing here is, okay, so I want to just check if any of them is null. So if root 1 is null, I want to return root 2, and else if root 2 is null, I want to return root 1. Basically, if any of them is empty, there's no point in it, means the answer is just going to be basically the other root. Since the other one doesn't have anything, it will just superimpose on it on nothing, and it will still be the same thing. So basically that's what I'm doing. And then if at this point I'm sure that my root has values, both of them, so I will just say root 1 dot val, and I'm putting whatever is in root 2 dot val. So basically I'm going to, so that I know that the top node already, I've sorted that one out, and then I don't need to bother about that in my merge trees, in this my DFS here, DFS here. I don't need to bother about that. So I will just have my merge trees DFS, and I'll pass in root 1, root 2, so that I know that if at this point what is passing here, these 2 roots, I've already put the value of 2 into 1, so I don't need to bother about that here. But I think I need to bother about the left and the right if both of them actually exist. So for example, I am saying that if the root 1 dot left, if it exists, and root 2 dot left is not null. So if both of them exist, for example here, well, let me just go to our board here. For example, where we have this existing and this existing, okay, those are the root nodes. Okay. So for example, when we have this left here existing and this left here existing, what we want to do is that we want to sum those values up and then go to the child node to see if we can do the same for the child node. So I want to, so basically I will just sum up root 1 dot left plus equals to root 2 dot left. Okay, so the value, sorry, so I need to put in the value. So I have put in the value from 2, I've summed it up with what is in 1, and I also want to do the same thing for the children. So I will just pass in that root 1 dot left and the root 2 dot left. So I'm passing out those two nodes so that the children can also be cross-checked, and it keeps going down that path. And I will do the same thing for the right side, for the right children rather. So the second root on the right, if both of them are not null, then exactly the same thing. So I'm just saying the left, or rather, since I'm on the right dot val, I want to add it with what is on the root 2, the right dot val, and then I want to also go through the children to see if I'm going to sum them up or whichever way I'm going to go with that. So the right, and then root 2 dot right. I think we are good. Let's run it and see. I think we are good. Yes, I think we're good. So let's just submit this and let's see how this goes. Okay, so we have an issue here. So this is noisy. Let me just use this use test case so I can see this graphically. Why will that not run? Let's see it again. So the test case, I want to visualize this. Okay, so I have a left here and I have a left and a right here. So this is supposed to superimpose on this, and then this becomes -3, and then when it goes here, since this doesn't exist, oh, so because of this return, when it goes to do this second, when it returns, because of this return, it will not. So okay, so this is a problem then. So okay, so what we could do is let's create a variable here for both of them. So let's call this don't skip left, and let's set it to true, and let's have don't skip right. Let's also set this to true. So what I will just do here is then set don't skip left to false, and I'll set here don't skip right. I'll set this to false also. So here I could just check if it's, so what the point I'm trying to make here is if it has come to the left, I don't want it to bother going to check this left again, because we have already done that check, the check for the left. So don't skip left. So if it is true, that means it didn't go through any of this. And then I'll do for don't skip right. Okay, so let's run this. I think this should take care of that. Let's see. Yes, okay. So let's try submitting again. Yes, and I think it passes. So there was the edge case where we had so let me just, it's not okay, I think it's here. That was the edge case where, because when we try to fill in what is on the right, when we put what is on the right and we return at that point, it doesn't allow it to come back to actually check the children of that which is on the left. And so that was the problem, because when it checks this right and it did it at that point, we had a return here, we're just returning it at that point. So this -1 will not superimpose with -2 to become -3. So that was the problem there. So, but with this now, we are able to tell it when it can skip. If it goes in here, we just tell it not to go through the left. If it was the left, and if it was the right, we tell it not to go through the right, based on the don't skip right and don't skip left variable we created. So basically, this is the solution to this. I hope this was clear. And if we had any issues or need clarification, just drop a comment and I'll try as much as I can to explain as much as possible. But basically, we still use the depth first search because, as you see, we kept going deep and we are checking, comparing the two routes on the left and the two routes on the right, if they exist, if both exist. But if both don't exist, then we just take whichever one that exists. So if because we are returning route 1, we know if it's route 1 that has and route 2 doesn't have, route 1 already has it. But if route 2 is the one we want to use, if route 2 is the one that has it, then we need to put the data into route 1, basically. So that's this algorithm. Please, as I said, if you have any questions or doubts or need clarification, please drop in the comment section and I'll try to respond. And thank you, and I'll see you in the next video.